changed so much, and one of the best things that happened to humanity is telecommunications. Today, we can call people on the other side of the world, send messages within seconds, and access information from almost anywhere through our mobile devices. Behind all of that are telecom operators and the networks that keep everything running. In the UK, people commonly use providers like Vodafone. In the United States, many rely on Verizon. In South Korea, SK Telecom is one of the major carriers, while in Nigeria, millions of people depend on MTN every day. Although these companies serve different regions, they all provide the same essential services: phone calls, SMS, mobile data, and cellular connectivity. These services have made life easier, but they also raise an important question. How do telecom companies know their networks are actually working properly? Because of this, operators constantly need answers to questions such as, are calls reaching customers correctly? Are caller IDs displaying the right numbers? Are there weak coverage areas that need attention? Could fraud or routing issues be affecting users somewhere in the world? And while answering these questions is important, doing so is not as simple as it sounds. Traditionally, telecom companies rely on laboratory simulations, synthetic testing, and dedicated probes to monitor their networks. But they still have limitations because real life is difficult to reproduce inside a controlled environment. People move around. Weather conditions change. Signal strength varies from one location to another. Someone using a phone in a busy city experiences a network differently from someone living in a remote area. Calls also pass through multiple networks before reaching their destination, which means problems can happen at several points along the way. Because of this, telecom companies need something simulations cannot provide. They need real-world data, and that is what U-Network is building. U-Network is a people-powered global edge network that turns everyday smartphones into contributors to telecom intelligence. The idea itself is actually simple. Instead of relying on a small number of expensive testing devices, U-Network gathers information from thousands of real phones around the world. Think of it this way. Google Maps understands traffic because millions of phones are moving around every day. U-Network applies a similar idea to telecommunications. Every participating phone becomes like a sensor, helping the network understand what is happening across real mobile networks. This approach falls under something called DePIN, which stands for Decentralized Physical Infrastructure Network. That sounds like a lot of words, but it simply means real devices providing real services, while the people contributing those devices receive rewards in return. So what exactly are these phones doing? One of their jobs is something known as CLI verification. Now, that sounds technical, but you have actually used it your entire life. Whenever someone calls your phone, the number you see on your screen is called caller line identification, or CLI. U-Network sends test calls to participating phones, and all the operator needs to do is confirm whether the displayed number is correct. The call does not need to be answered. This helps telecom companies confirm that calls are being delivered correctly and also helps detect routing problems or inconsistencies. Another important task involves collecting information about network performance. Things like signal quality, coverage patterns, and network trends are constantly changing. Now, whenever thousands of devices are contributing information, one question naturally comes up. How do you prove that the data has not been changed? This is where blockchain enters the picture. Blockchain simply acts as the proof layer. U-Network records results through World Mobile Chain, also known as WM chain. Before information is stored, it is converted into a unique digital fingerprint, known as a hash. This creates records that can later be verified, providing transparency and trust throughout the system. Behind all of this is a collaboration between Minutes Network and World Mobile Chain. Minutes Network brings telecommunications expertise, while World Mobile Chain provides the infrastructure used to verify and secure information. Participating phones form what is known as the edge layer because they collect information directly from the real world. That information then flows through other parts of the ecosystem, including switch nodes, validation nodes, and earth nodes. Together, these systems help keep the network running. Of course, understanding the technology leads to another question. How can people participate? U-Network offers two ways to join. The first involves node software licenses. Only 6,000 of these licenses exist, making them a limited resource within the ecosystem. Each node license comes with 200 operator licenses and allocations of MNTX and WMTX tokens. These licenses are represented as NFTs on-chain. The second option is much simpler. People can lease operator licenses through the U-Network application, install the app on Android or iOS, connect a wallet, activate their licenses, and allow tasks to run quietly in the background with minimal impact on their devices. And naturally, participation brings another question. How are people rewarded? U-Network follows a utility-driven model. In other words, rewards are supported by actual demand. Telecom companies and enterprises pay for the services provided by the network. 75% of those fees go to operators, while the remaining 25% strengthens the broader ecosystem supporting MNTX and WMTX. Rewards can be withdrawn in several cryptocurrencies, including Bitcoin, Ethereum, ADA, DOT, and USDT. More recently, users also gained the ability to withdraw directly to bank accounts in USD, EUR, and GBP, helping bridge digital rewards with traditional finance. At this point, some people may be wondering about privacy. Fortunately, U-Network does not access contacts, call conversations, or personal content. Most activities involve background network checks, and an active SIM card is typically required only for CLI-related tasks. Another interesting part of the ecosystem is scarcity. Only 6,000 node licenses exist. As more activity enters the network, more service fees are generated, and those fees strengthen the ecosystem.